Okay. The topic's name, physical properties. Yesterday, method of preparation was completed. Today, present physical properties. Now, if you look at haloalkanes, so before doing physical properties, let me tell you what are we going to learn here? In physical properties, we are going to compare the boiling points, melting points, and the solubility. Okay. And in general, we'll be only talking about boiling points for the next chapters, but somewhere here and there in few chapters and few points, we'll be talking about melting points also. Now, first of all, we understand what is boiling point and where does it depend on. So boiling happens when the molecules in liquid, they are attracted towards each other. And when you decrease the force of attraction or you make them apart, force them apart from each other, after a certain point of force of attraction, they will become completely not attracted to each other. They will not repel each other, but they will not be influencing each other. And at that time, they become gaseous molecules. So they will boil off. Now, boiling point depend on the force of attraction between two molecules. So this is important. We have to understand force of attraction. Now, what are the different types of force of attraction? There are a few force of attraction that you have to remember, and their order of magnitude, which is the strongest force of attraction, which next, and which next. Okay. So the most strong force of attraction between two molecules, if you are talking, then the most strong is hydrogen bond. Then after hydrogen bond, you will be having highly polar molecules. You'll have polar molecules. So in polar molecules, you will have dipole-dipole interaction. And after this, you will be having the non-polar. Okay. So hydrogen bond is formed when a molecule has hydrogen bonded to fluorine, oxygen, or nitrogen. Now, polar molecules, wherever you have polar bonds, that means there are atom A and atom B. Both of these are connected, and atom A and atom B, they have different electronegativity. If B is more electronegative, it will get delta negative, and this will get delta positive. Another A and B will be there. Now, both of these will also get delta positive and delta negative. Now, the B is partial positive charge, and A is partial negative. B is partial negative charge and A is partial positive charge. They are going to attract each other. So this is dipole-dipole interaction. Okay. In non-polar, what is going to happen? You will have only van der Waals force of attraction only because of instantaneous dipole. So I have AA molecule and another AA molecule. So for some instant, what can happen? For some instant, there will be higher polarity in delta in A, and it will get delta negative, and that is why it will pull the positive part of this molecule, and it will get positive charge. So momentarily there is some charges, but actually these are what non-polar molecules. They don't have any dipole moment. Okay, so all of you understood this? Yes or no? Please tell me. Hydrogen bond, polar molecules, and non-polar. Whenever there is hydrogen bonded to fluorine, oxygen, or nitrogen, it is going to have hydrogen bond. Polar bonds when there is electronegativity difference between two atoms. Non-polar when there is no electronegativity difference between the two atoms. All of you got this? Yes or no?
Then how non-polar are bonded?
They're not bonded, no. I'm talking about force of attraction between two molecules, not inside one molecule. This is one molecule. This is another molecule. So between these two molecules,
but
there is
what is in the case of non-polar?
In non-polar, you will have instantaneous dipole. Can I say for instantaneous means, see, this is because you guys did not do states of matter. No? States of matter has been removed. So instantaneous, what happens? This is AA molecule. And this AA molecule will be something like this, right? In reality, I'm speaking. They will if you have a microscope and you look at an atom, that atom will not say A. That will have some sphere, right? And there will be charges around. Now, for an instant, can I say that there will be some positive charge and negative charge will be separated, can be separated for an instant meaning. Because charges are moving here and then, and positive and negative charges are separated. Similarly, what can happen with another, as soon as there is an instantaneous dipole, just next to it, there will be another molecule, and these positive charge what they will do, they will attract the negative charges and they will be like this. So this here now is going to have force of attraction.
Yes, sir, understood.
Okay, so this is instantaneous. For an instant it will be there. Okay. Now in non-polar we don't have any dipole moment. Now after this, please write. If you look at haloalkane, then haloalkane has a Rx bond. Carbon halogen bond. Now the carbon halogen bond here, it will be having, halogen is more electronegative, so it will pull the electron, making it delta negative, and R will become delta positive. R will become what? Delta positive. And that is why these are polar molecules. So please write. Haloalkanes have higher boiling point than non-polar, higher boiling point than non-polar hydrocarbons. Due to greater polarity and larger mass, larger molecular mass. Okay. Now, when you look at the molecular mass, why does it depend? When you have large molecular mass, there will be large number of protons, there will be large number of electrons. And if there is large number of protons and electrons, the dipole will be even more. There will be more negative charge in one side, there will be more positive charge in the other side, because we have more number of electrons. Okay. That is why you will have this molecular mass is also independent. If I compare different haloalkenes, then in that case, for a given haloalkane, the boiling point depends on the number of carbon atoms. Is right? For a given halogen atom, boiling point depends on the number of carbon atoms. SCX Okay. Now, obviously, when you have less number of atoms, there will be less protons, there will be less polarity. That is why it depends directly on the number of carbon atoms if you have same halogen atom. Okay. So if they give you an example like this, compare them. All of you understood this? Yes or no? Please tell me. We will do an example at the end. Understood, na? That if you have
Sir,
more number of carbons, yeah.
sir, 1 minute. We saw a order before, right? H bond, polar molecules, non-polar molecules. This is of polarity.
Yeah, this is for force of attraction and polarity, both of them.
Okay, so force of attraction and polarity are not same.
No, they are not same, but they are directly proportional. If there is a
Okay.
large polarity, then there will be large force of attraction also.
Okay, sir. So polarity means how it is attracted.
No, polarity means, so you have learned dipole moment in physics.
Yeah.
So that is polarity. It does not tell you about it. It tells you about attraction, but it is not attraction exactly. Dipole moment and attraction are directly related to each other, but both are not the same thing. Got it? Yeah.
Okay, sir.
So you understand now, if you have
So
something
this
like
is related to dipole moment, that is related to attraction.
yeah, tell me if you have positive and negative like this, okay? And then there is another positive and negative. So these are dipoles, right? Yes or no?
Yes, sir.
So this one box is one molecule, this another box is another molecule. And now can you tell me there will be attraction between these two now? Yes or no?
Yes, sir.
Okay. Now this is a type of dipole. Well, I am telling another dipole. Okay. So let us suppose you have two positive and two negative charge. Here also you have two positive and two negative. Now the dipole is greater in this case because we have more charge. Correct?
Yes, sir.
So there will be and two negative and two positive, they will be attracted also more. Correct?
Yes, sir.
That's it. That's why I'm saying the dipole can tell you about attraction, but it is not attraction. Okay.
Okay, sir.
Please write here. For a given hydrogen atom, boiling points depends on these things you have to remember, but okay. If you don't remember dipole, if you don't, but these things you have to remember. Otherwise, you will just be deriving each and every concept that we are writing. These things you have to remember. For a given halogen atom, if the halogen atom are same, then you are going to look at what? The number of carbon atoms. Right, next. For a given alkyl group, boiling point depends on the molar mass of X. Molar mass of the halogen atom. That means if the alkyl group is same. For example, if you have alkyl group bonded to F, then you have alkyl group bonded to chlorine, you have bonded to Br, you have alkyl group bonded to iodine. Now, since iodine has more molar mass, you don't need to compare the alkyl group. Now you need to compare the halogen atoms. For example, next point, please write. Boiling point is inversely proportional to branching. Then we will explain why branching it is inversely proportional. Please let me know once you're done writing. Then yes or no, please tell me.
Then, sir.
Now please. All of you remember dipole moment is given by mu. It is equal to the charge multiplied by distance between the charge, right? Yes or no? All of you know this, Deborah, Fia, Hafsa, Mariam, Khatun. No, you have not learned dipole moment. Tell me, Deborah, Fia, Hafsa. Deborah, अब आप बात नहीं करेंगी. हाँ? Deborah, am I audible? Yes, Fia, you tell me. Hafsa, Mariam, Khatun.
Yes. Yes, sir.
Yes, na? Q into D. You remember? You know this, yes or no?
Yes.
Okay, fine. Now please. It is inversely proportional to branching. Let us suppose I am taking 4 carbon atoms. 4 carbon atoms and a Br group. Now we have here 1, 2, okay, I have taken 5 carbon atoms. My bad. Let me take 4 only. 4 will do the work. 1, 2, 3, 4, and we have Br atom. Okay. Now branching has increased, right? Branching has for sure increased. We can increase branching even more like this. Br is here. We can increase it furthermore. Br is same. Okay. Now, if you calculate the distance between delta positive and delta negative, it is becoming very short. Can you see? Please see here. So Br is attracting electrons, it will get delta negative. All the carbon atoms, delta positive, and this carbon atom will also get delta positive till here. So this distance is quite large. Okay. Now the largest distance that you are going to get in the second case is what? Br is having what? Delta negative here, right? And this carbon will have delta positive, right? That is the largest distance that it can have. This is not this carbon atom, because this is also delta positive, it will also get delta positive charge, but that's not the longest distance it can have. So this is going to have something like this dipole. And as you can see, it is a bit smaller, right? Yes or no, please tell me. Here also this Br is going to have 1, 2, 3, 4. Yeah. So here you will have delta negative, and here you will have delta positive. Now this is even smaller. If you look at this one, any one of the carbon atoms will get delta positive. It's going to be very small delta positive. If I take here and like this, it's going to be very small now. As the D decreases, the dipole moment will also decrease, and the force of attraction will also decrease. That is why when in boiling point, if there is more branches, then the boiling point is what it is, lower. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. So the order is going to be, this is going to have the maximum boiling point, then this, and then this. That goes down, let me know once you're done. So how will you check for boiling point? The first thing that you are going to check for boiling point is number of carbon atoms. If the carbon atoms are large in number, then that will get the highest boiling point. Number of carbon atoms in haloalkane. Okay. Second point that you are going to look for haloalkanes after the number of carbon atoms. If the carbon atoms becomes equal, then how are you going to? Then what are you going to do? The number of carbon atoms are same. Then you will look at the halogen atom. You will see the molar mass. Now, if the halogen atoms are also same, then in the third case, what you are going to look at? Branching. Number one, number of carbon atoms, then halogen atom, then molar mass. And got this? Yes or no? Please tell me. Tell me, guys. All of you got this? Understood now what you need to do? Now, see a question.
Yes, sir.
See, in your textbook, maybe they have given the names, but I'm writing the structure here, and you will tell me CH3Br. The B structure is CHBr3. The C structure is CH3Cl. And the D structure is CHBr2. Now compare the number of carbon atoms and tell me. All of them have same number of carbon atoms, yes or no? All of them have same
Yes,
number of
sir.
carbon atoms. Right. So that is why we cannot decide on the number of carbon atoms. We'll have to look next. That is the halogen atom. So which is the heaviest halogen atom, bromine or chlorine? Because here you have only bromine or chlorine. So which is heavier, bromine or chlorine?
Bromine.
Bromine is heavier. And where do we have maximum bromine in A, B, C, D?
CH2, CH.
No, A, B, C, D. In A, B, C, D, where do we have the maximum number of bromines? You look at A, B, C, and D and tell me, where do you see maximum number?
B.
Where? B, right?
B.
B will have the maximum boiling point, followed by D, followed by A, and followed by C. Understood?
Sir, but CH3Br has the hydrogen atoms no need to take?
No, hydrogens, don't need to
Okay,
take
sir.
hydrogens. Only if you have written it. No, what I have written, that's it. You don't need to put anything further. Everything is here. Got this? Yes or no? Please tell me. All of you understood this? Yes or no?
Yes, sir.
Now, please remember,
Yes, sir.
the questions will not be asked like this. They will ask you boiling point, but they will give you the name of these molecules. So from name to molecule, you have to make. From name to structure, you have to make. Okay. So this was the first question. And since we are not focusing on the nomenclature here, that is why I'm just writing the structures. Next question is, let us suppose you have a structure in which 1, 2, 3 carbon atoms and chlorine. B structure is 1, 2, 3 carbon atoms and chlorine here. And C carbon atom is 1, 2, 3, 4 carbon atoms and chlorine. First of all, look, which one has the maximum number of carbon atoms? A, B, C. Where do you see maximum number of carbon atoms? C. So C will be having the highest.
C.
After that, C, right? After that, which is having the highest number of carbon atoms? A or
A.
B? A is
A.
having large. A is having more carbon atoms. How many carbon in A? How many carbon in A?
3.
And how many in B? How many in B?
3 carbons, sir.
3 carbon atoms. So both are having same number of carbon atoms. Then you will look at the halogen atom. So A is having Cl, B is also having. B is also having. Answer it, guys. Why you don't answer? Hafsa, Mariam Khatun, you don't hear my question. You cannot see what halogen atom is present. What halogen atom is present in A and B?
Chlorine.
Chlorine. So we cannot decide on chlorine. Then you will look at third thing, that is branching. So which has now branching, it is inversely proportional. Okay, please remember that. So branching should be less. I will write it like this. Branching should be less. That will get more boiling point. So which has less branching, A or B?
A.
A has less branching. So C, A, and then B. All of you understood this? Yes or no, please tell me. All of you understood this?
Yes, sir.
Okay. All right, next, melting point. Okay. Now, first of all, melting point, it depends on two things. Melting point depends on the force of attraction also. And because melting point, we talk about melting point of a solid. And when you have a solid, it also matters how solids are packed. That means water can be only flowing. Water does not have a specific structure. But different solid, they have different structures, and how they are packed, how the atoms are fit together, that also matters. Okay. That is why there are two things. On which melting point depends. So melting point depends on, first of all, please write, melting point depends on, number one is intermolecular forces of attraction. And second point is packing. Now, for example, if you have atom something like this, I'm just telling particles something like this. Boxes will fit very strictly together, right? But if you have something like this, let us suppose you have some adha teda shape, not this, but rather like this. So you cannot fit something here, right? One thing will come here and it will go like this. So there is some vacant spaces. It is not fitting together. So if you have symmetrical structure, it will fit better. If you don't have symmetrical structure, it will not fit better. So write a point here, symmetrical structure leads to better packing. Symmetrical structures leads to better packing and higher melting point. And higher melting. Okay. Now that is the reason P-dichlorobenzene has higher boiling point, sorry, higher melting point than its O and M isomers. If you look at p-dichlorobenzene, para-dichlorobenzene, it is something like this. So it is symmetrical in nature. But if you look at ortho, not symmetrical, and meta is also not symmetrical. Okay, so that is why their packing is not good. P-dichlorobenzene has higher melting point than its one M isomer because of symmetrical structure and better packing.
Sir, in this melting point, it is of the para position, and for boiling point, it will be ortho position.
No, I mean, you cannot determine the ortho because these are completely symmetrical.
Okay, sir.
For boiling point, you cannot predict. You have to look at the values. They will not ask you questions for boiling point. Okay, because
Okay,
you
sir.
cannot predict for it.
Done, sir.
Dipole moment. Okay. Now, in dipole moment, there are a few points that we have to write. First is haloalkenes has greater dipole than haloarenes. Because CX bond in haloarene has partial double bond character. Has partial double bond character due to resonance and therefore shorter. Okay. First thing is that. Another reason is also carbon in CX bond of haloarene. This is arene. Also carbon in CX bond of haloarene is sp2 hybridized. Is sp2 hybridized. Greater electronegativity. Due to which the CX bond has low polarity. Okay, so first reason you can easily understand. since mu is equal to what? Q into D. And if the CX bond is larger, the distance will be larger. And if the CX bond is shorter, the distance will be shorter. And the value of dipole moment will be lower. Value of dipole moment is going to be lower. Another thing is that why is this dipole moment existing? Because this halogen atom is able to pull electron. It is why it is able to pull electron? Because it is more electronegative than carbon atom. But which carbon? We have three carbons, right? We have sp carbon, we can have sp2 carbon, we can have sp3 carbon. So in haloalkane, we have sp3, but in haloarene, we have sp2. And sp2 carbon, these are more electronegative because they have more S character. If you look at the S character, if you don't remember from the chemical bonding, it's very easy thing to know. If you look at sp carbon atom, it is okay. If you look at sp carbon atom, so sp carbon atom, they will have hybrid orbital with sp hybridized orbital. So in sp, you have 50% S and 50% P. In sp2, what you will have? You have one S and two P, right? So it is going to be, this is 33% and this is 66%, you know, approximately speaking. This will be 33.3 and this will be 66.6, okay, for that matter. So sp2 is going to have 33 and 66. sp3 is going to have S character. How much S character will be? 25, and P character will be 75. Now, where you have larger S character, that hybrid orbital will be nearer to the nucleus and they can pull the electron more easily. That is why sp can pull the electron most easily, then sp2 and then sp3. So in haloarenes, we have sp2, which is greater in electronegativity than sp3. Now, if this is carbon is also trying to pull electrons, halogen is also trying to pull electrons. So at the end, what is going to happen? No one can pull the electrons much effectively, right? That is why this particular bond, it is polar, but it is not as polar. Because carbon also has a tendency to pull electron. Even though halogen has a greater tendency to pull electron, but still carbon has some tendency to pull electron. That is why the net pull from the halogen atom is not very good. And that is why what happens? It has low polarity. And low polarity means low dipole moment. All of you got this? Yes or no? Please tell me. All of you understood these points? Okay. So there is a question in NCERT that why is cyclohexane, one chlorocyclohexane, why does it have greater dipole moment than chlorobenzene? So obviously they are going to have, right? Or they, if you want to compare chlorobenzene like this, and you have this is cyclohexyl chloride. Oh, sorry, not this ring, just a chlorine here. So obviously this is haloalkane, this is haloalkane. So haloalkane will have higher dipole moment. This will be in, I think, 10.12, 12th number question. I remember this question because here you have 6 carbon, here also 6 carbon. So 6, 6, 12. Then everyone is going to please tell me.
Yes, sir.
Right, next. There's again a question on comparing the dipole moments. So dipole moment is a scalar or vector? What happened, guys? Dipole moment is scalar or it is vector?
It is vector, sir.
Vector quantity, right? So see. Compare dipole moments and we have CH2Cl2, then we have CHCl3, and then we have CCl4. Okay. So let us now make the structures. So all of these carbons are one carbon atom and it will be tetrahedral structure. That is why I'm writing dash. That means it is coming out of the plane and this is going inside the plane. So similar type of thing will be there in the other two also. I have not written which hydrogen is where and chlorine is where. Just write this one first, then I will write the hydrogens and chlorines also. So in the first case, I will take the hydrogens in the plane and one chlorine is coming outside and other chlorine is going inside, but both of them are in different SNE, they are opposite, right? It's not that they are completely opposite. So this is, both of them are coming. This chlorine is coming outside of the screen in the right direction, and it is the other chlorine is going in the right direction also inside the plane, but it's going in the right direction. Right means left, right. Okay, so let us take hydrogen here, the chlorine here, and this chlorine here, and this chlorine here. In CCl4, you'll have chlorine here, chlorine here, chlorine here, and chlorine. Now, since we have only chlorines, and all the chlorine will have delta negative charge. Chlorines are not very good actually. It's fine, I think. Yeah. So all the chlorine will have delta negative, delta negative, delta negative. Carbon will have delta positive. So there will be a dipole moment. All these are going to have dipole moment. So what I will do, I will resolution of dipole moments. I think there is something called, right? Resolution of dipole moment. So in the plane, I will make a dipole moment which goes like this. I will resolve this and this, right? And I will get this one. Similarly, I will resolve the inside and outside. Then I will, now one is going inside and the other one is going outside. That means the resolution will be on the plane. So the resolution of both of these are what in the middle, that is on the plane, and which will be having downward direction in towards the left, like this. Correct, guys? Yes or no? Please tell me. Is that right? You understood the resolution? Yes or no? Please tell me. Oh, Fia, Hafsa, Mariam, Fatun, and Deborah.
Sir,
Yes.
can you repeat?
Oh.
Can you repeat
You
it,
know
sir?
how to resolve, you know, right? If you have a vector here and if you have a vector here like this, then you have the resolution of these two vectors are going to be here, right? Yes or no? No.
Yes, sir.
That's what I have done now. So this is dipole. This is another dipole. So its resolution, it will be in somewhere in the middle. I'm approximating things. We are not calculating. We are approximating things. Okay. Similarly, just imagine the Cl coming out and Cl going inside. So their middle part will be on the plane. Correct. And that is why I have
Yes,
drawn that also on the plane. And can you see both the vectors cancelling each other? Right? Both are cancelling each other. Yes or no? No, they're
Yes,
not
sir.
cancelling each other. They're cancelling each other, right? That is a mu net. The net dipole moment here will be equal to 0. The net dipole moment will be equal to 0. Now, let us look at this case. In this case also, this chlorine is going to be delta negative. That's why there will be a dipole here. And now this dipole will be something like this. The hydrogen dipole, this is like this. The hydrogen dipole will be like this because carbon is going to pull electrons because carbon is attracted with 3 chlorine atoms. Okay, so hydrogen is not more electronegative. Carbon is more electronegative. So this dipole is towards the downward, and this is towards the rightwards. So I don't know. It will be something like this, and maybe something like this. There will be some downward direction kind of thing, right? Yes or no? This will be dipole, maybe.
Sir, how can that occur between that two thing? Because one is in other direction, other is in other direction.
But we have to resolve it. How do we resolve?
Instead of that, you can take this C and this Cl, no, down one.
No, I'm going to keep these CLs same because I have a very good resolution for these two now. Anyway, I'm going to have a trouble, right? But I'm not going
Yeah.
to Chedkhani this one. I'm not going to disturb this one. Okay. So I don't know. We do something like this, and I guess we do something like this. If you have some, this is the dipole right now. So I think maybe we can take it like this, no? No. And then resolve it, right? Correct. And it does not
Yes,
happen
sir.
like that. Something like this we do now. Okay. So whatever it is, you are going to get something in the downward direction, but towards the left. You're going to get something towards in the downward direction, towards the left, right? Yes or no?
Yes,
Correct.
sir, because of chlorine atom.
Because of chlorine. Now this dipole is downward and left. This dipole is also what? This dipole is also downward, but this dipole is downward and right. Downward and right. This is downward, but it is left, right? Now what
Yes,
is going to
sir.
happen? This left and right will cancel each other out. You will get a net dipole which is downward only. So there is some cancellation happening, correct? There is some cancellation. Mu net is greater than 0. Mu net is greater than 0. I will write mu net. It is greater than 0, but some cancellation is happening. Now, if you look at this one here, now this carbon will have like this dipole, this hydrogen will have like this dipole, and this will have a dipole like this. Okay. Now this is downward and this is what? Upward, right? So you can see that, and both of these are going to, both of these are also facing towards the same thing only, right? They're facing downward and right, downward and right. So here there is no cancellation. There is no cancellation, and you are having this pure dipole moment. That is why this will have maximum, then this, and this, because there is no cancellation. There is some cancellation here, there is all cancellation. So just by looking at the structure, we can predict. We don't have any values, so we are just going to have relative idea that which is going to have higher dipole, which is going to have lower dipole. Understood this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Write this down. Write this down. Let me know once you're done. Done writing?
So in the first case, there is no dipole moment.
The first case, there is dipole moment, maximum dipole moment. In the last case, there is all cancellation. Here you have nu net max. Because there is no cancellation, the dipole moment exists here. This is max. See, max I have.
So here there can be only one dipole moment, not two.
No. What do you think? Two dipole moment, that is better. That's not more, no?
No. Here we have two dipole moment, like two arrow marks. Here only one we have, right?
No, there will be only one dipole in all the cases. There will be either, see, I can resolve these two also, right? And the, see, left and right, they cancel each other and you will have one dipole moment that is in the downward direction. Correct?
Yes, sir.
But here we have only one dipole moment which is on the down right, and it will be maximum because this dipole moment is not cancelled by anyone.
Okay.
Got, I know. So that is why this will be maximum because it is not getting cancelled by anyone. Done writing. All of you done writing? Yes or no? Please tell me. No. Let me know if you're writing, guys. तो कोई जवाब ही नहीं देता है बिल्कुल, हाँ ना कुछ नहीं बोलते हैं लोग. Right, next solubility. Please write. Haloalkanes are very slightly soluble in water. Soluble in water as they cannot form hydrogen bond with water. Okay. So slightly soluble, it also has another word for it. It is known as immiscible. CIBL. Okay. We can also write why haloalkanes are immiscible in nature. Or they will ask haloalkanes are polar, but they are immiscible in water. Why? So you will just write haloalkanes are immiscible in water as they cannot form hydrogen bond with water. Next point you will write haloalkenes are soluble in organic solvents.
Done, sir.
Done. So that's it for the physical properties. Now we are going to write about chemical properties, which we are going to discuss it on Saturday now because this is Thursday, right? Okay, chemical properties. Of haloalkenes. So there are three reactions that we have to learn. Number one is nucleophilic substitution. Three types of reaction, not three reactions actually. Nucleophilic substitution. Secondly, elimination reaction. And third is reaction with methyl. Yeah. Got this, guys? Yes or no? Please tell me. Okay, so we'll start with nucleophilic substitution tomorrow. Not tomorrow, Saturday. No, tomorrow you don't have a class. Tomorrow is Friday. This time पे जुमा की अज़ान हो जाती है तब तक यहाँ पे. ठीक है. So you'll have the next class on Saturday. Wrote this? Yes or no? Please tell me.
Yes.
Sure.